Hi viewers, welcome to LMS Solution. Today we are going to see about vehicle to grid and grid to vehicle concept in MATLAB. In this video, we are going to implement ATG and GDMU in the single phase grid. This is a simulation model and developed for vehicle to grid and grid to vehicle and single phase grid. So this is consists of single phase grid that voltage is around 325. That means for 230 volt RMS, the peak amplitude always 325 volt, and then here we consider the frequency of a single phase grid is 50 hertz, and then this is source inductance, and this is single phase bridge inverter, and this is DC link capacitor, and this is bidirectional DC to DC converter. There been bidirectional buck boost DC DC converter. It is having two switch and then filter, inductor and capacitor, and then this is battery. Here we are using 120 volt battery and rated capacity is 48 Ah. Here in this model, here we need to maintain the voltage across these DC link capacitors around 380 volt, and also we need to make the power factor of source side always unity. Here we need to apply two control method. One is DC link voltage control. Another one is current control. The current control used for maintaining the unity power factor in the source side. Further, here we are measuring the DC link voltage. It will be combined with the reference voltage 380 volt, and then it will be processed via PA controller. This PA controller will be generate the reference peak magnitude for this current control. Here we have only the peak magnitude that should be converted into sinusoidal nature. For that, we are going to measure the grid voltage, and then we are using PLL. PLL nothing but phase log low, and then by using PLL, you have to generate omega t, and then the omega t is processed via sine block. That means we are calculating sine omega t. It will generate the sine wave. That means unity amplitude sine wave. It when we multiplied with the peak reference current, then you will get the actual reference current in the sinusoidal nature. It going to be follow the nature of the grid voltage. So next, this reference current going to be compared with the source current or grid current. This is source or grid current. This current going to be compared with this reference current. Again, it going to be processed via PA controller. This PA controller will be generate the control voltage in the form of sinusoidal nature, and then it going to be processed via a pendulum generator, sinusoidal pendulum generator. The output of this pendulum generator is given to the single phase H bridge pendulum inverter. It going to be control this the single phase H bridge inverter IGBT in order to send the power from the grid to battery or battery to grid, and this system always operate under unity power factor condition, and also the T is will be always less than 5%. For that only we are creating this control, the DC link voltage control and the unity power factor control or current control in the AC side. So next you have to implement the current control logic. Current control logic for this bidirectional buck boost DC-DC converter. For that we are going to measure the battery current, and the battery current going to be compared with the reference current. This error current will be processed via the PA controller. The PA controller output known as duty cycle. This duty cycle processed via pendulum generator. Here we have generated only one pulse. The first pulse going to be given to the upper IGBT of the bidirectional converter. The inversion of this pulse going to be given to the lower switch of the bidirectional converter. This control going to be control the current flow in the battery for charge the battery from the grid to battery side, and then discharge the battery from battery to grid. This battery going to be act as a vehicle battery. Based upon this current command, the V2G and GTV concept is implemented here. That means vehicle to grid means we are sending power from vehicle battery to the grid. So grid to vehicle means you are sending power from grid to vehicle to charge the battery. So vehicle to grid means battery going to be for discharging operation, and the G2V means the battery going for charging operation. This is a Simulink model of that vintage and GTV and the single phase grid model. Next, I am going to explain the simulation with cells. Here, I am using step input. For that means I am going to change the reference current for the battery Initially, I'm going to make the reference current is 10 minus 10 amps. That means I'm going to charge the battery from the grid. Now it going to act as a grid to vehicle concept. The grid going to be supply the power to the battery to charge the battery. After 0.5 seconds, I'm going to change the battery reference current from minus 10 to 10. During that time, the battery change the state from charging mode to discharging mode. Now the model will be operate in the concept of vehicle to grid concept. That means the battery going to be supply the power to the grid. So you have to check the detail. So in order to check the detail, we have different scope. This scope used to for measuring the source voltage and source current, and then this scope used to for measuring the DC link voltage, and this scope used to for measuring the battery SOC, battery current, battery voltage. Now I am going to simulate the model and then we will check the results. The initial battery going for charging mode. Now you can see that the battery current is maintained at minus 10 amps and battery voltage is around 120 volt. So here you can see that the battery SOCs keep on increasing. That means battery goes charging mode. That means grid to vehicle concept. And then you can see that this descending voltage is maintained around 380 volt. And then you can see that this is a source voltage in source current. At the time of 0.5 seconds, the reference current changed from minus 10 to 10. Because of that, what happened? The battery current changed the direction from minus 10 to 10. That means now the battery current is plus 10. That means battery goes on discharging mode. You can see that the SOC of the battery is decreased from this point to this. And also you can see the battery voltage maintained at 120. And here during the change of reference current from minus 10 to 10, they have some overshoot, and then after some time, after 0.1 second is settled to 380 volt, and during changing of current reference from minus 10 amps to plus 10 amps, there is a variation in the source current. After 0.1 second of 2 or 3 cycles, they come back to the normal position. This is a working of the VTG and GTV concept in the single phase grid. And also I will explain one more thing. During charging mode, you can see that during charging mode, the source voltage and source current having unity power factor. You can see the current and voltage angle. Both are same. Both are in phase during that charging mode. And the grid going to be supply the power to the battery to charge the battery. During the condition, voltage and current should be in the in phase condition. Here you can see that during discharging, both phase angle will be out of phase. The voltage and current both are in a 180 degree phase difference. So during discharging, but in this condition also power factor is unity because cos 0 cos 180 always equal to 1. Power factor will be unity. Only the difference during charging and discharging. During charging, both are in phase. During discharging, the source voltage and source current are out of phase. So next you have to see the THT of the source current during charging and discharging. So I need to use 0.3 seconds and then I'm going to measure the THT. Here you can see that the THT around 4% only. This is less than 5%. It follow the IEEE standard. During discharging condition, I'm going to measure the THT. So here also you can see that the THT around 3.71% only. During discharging condition also, the THD is less than 5%. It followed the IEEE standard. Now I'm going to test the model with the change in current reference from 10 to minus 10. We will check the response of the source voltage, source current, and then battery SOC, battery current, battery voltage, and DC link voltage. Here you can see that from initially we have the reference current 10 amps. It maintained 10 amps, and then battery goes to discharging mode. Now battery discharging mode. After 0.5 second, the current will be changed from 10 to minus 10. Current will be changed here 10 to minus 10. Now the battery goes to charging mode. Here you can see that battery goes to charging mode. During that change of reference current from 10 to minus 10, the DC voltage have undershoot for the 0.1 second. After that, it going to reach the reference voltage 380 volt. Here you can see that during the change of current reference from 10 to minus 10, so there is some deviation, that means transition in the current. After 2 or 3 cycles, it goes to normal condition. During that time 0 to 0.5, that means when reference current is 10, it going to be act as a vehicle to grid concept. When reference current is minus 10, it going to be act as a grid to vehicle concept. and also you can see that the phase difference. And now you can see that during discharging condition it will have 180 degree out of phase voltage and current. During charging condition you can see that both are having in phase. Here you can say both are voltage and current are in phase. Now also I'm going to check the THD. Now we can see that the THD is around 3.59%. You must change the detail as same as the maximum frequency 0.3. Here you can see there the THD around 3.79% only. So during this condition also the THD is less than 5% only. Follow the IEEE standard. So this is the working of vehicle to grid and grid to vehicle concept in single phase grid. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you. Thank you so much. Bye bye.